Today we're going to cover the basics of 3D scanning and processing in Artec Studio. After watching this video, and with a little practice, you should be able to successfully and accurately reproduce most objects with your Artec scanner. Okay, today we're going to be working in Artec Studio 10, but pretty much everything we're going to cover also applies to Artec Studio 9 as well. So you'll be fine if you haven't upgraded yet. It would be helpful if you check the video description. There should be a link there to download a PDF guide that gives you a step-by-step process of everything we're going to go through today. So let's start our webcam here. You'll be able to see this turntable that I have. We're going to scan this little sumo wrestler. What I'm going to be using today is the Artec Spider. The scanning and processing tips apply to the Space Spider and to the Artec EVA. The scanning distance, of course, is going to be different on the Artec EVA, but the best practices and steps will be the exact same. Okay, so the first thing we're going to do is check our settings over here in the panel. So for the most part, when I'm scanning, most of the time I want to leave things on geometry plus texture. If you have an Artec EVA Lite, then you only have the geometry option. So I'm going to do geometry plus texture for tracking. We will talk about real-time fusion in just a second. For my scanning speed, I'm going to leave my frame rate as high as possible. That will make scanning much easier. I'll be able to move quicker. For the EVA, this of course is showing the Spider frame rate, which is about 8 frames per second. 7.5 is what you'll typically get. On the EVA, you'll get around 14.5, 15 frames per second. Depth of field, I'm going to leave right as it is. And we'll talk about texture brightness, and then if I expand this advanced tab, we're also going to look at the sensitivity option briefly. So step one in that PDF is scanning, of course. I can either press the preview button here in the software, or I can press up once on the Artec Spider, or on the EVA, you can tap the play button on the back, and it will give us this little preview here. This preview allows you to orient the scanner and make sure you are pointed at the object and you are the correct distance from the object. If you look over here on the left-hand side of the screen, you've got this bar that shows 330 to 170 for the Spider. It's 1,000 to I think 400 or somewhere in that range for the EVA. You want to keep the majority of this waveform that you're seeing here in the middle of these in these three center bars. That is going to give you the best scanning results. That's the optimal range. The further you are from your object, the more noise there will be. The closer, the better you'll have the better your scan will come out. So try to keep that distance meter mid to low on that meter there. If I go too close, notice it disappears. If I am too far away, my object also disappears. So watching that distance meter in preview mode and then while you are scanning is very important. And then when I do start scanning, I'm going to watch my screen and not the object that I'm scanning. Let's look at texture brightness. You adjust texture brightness to give you a more ideal brightness. If you're scanning very dark things, then you will want to maybe adjust your texture brightness up a little bit more. We're going to leave it about right here for this object. This works just fine. And then sensitivity. So there are some notes under scanning on when you would adjust your sensitivity. I'm going to leave it low for now, but it's basically like adjusting the gain on a camera. So I can adjust this up if I'm having difficulty picking up the surface of whatever I'm scanning. But I'm going to leave that down there. I'm going to collapse my advanced pane. Okay, so I'm still in preview mode. I'm going to press either record on the screen there or press up once more on the scanner. And now I am recording. So I have this nice little inexpensive turntable that I picked up. It was about $15. It works really well with the texture tracking because of the wood grain texture. And I'm just going to turn around like this. So what you want to do is scan this from multiple angles. And this applies to the EVA and to the Spider. Both scanners scan best when they are perpendicular to whatever object you are scanning. So you do want to scan your objects at many different angles for best results to fully cover your object. Okay, I'm going to press down on my scanning button on the back to stop it, or I could have pressed stop on the screen with my mouse. I want to capture the complete object here, so what I'm going to do is turn it over, and we are going to get another scan like this. Since I will be aligning these, I'm making sure that I have enough common captured geometry from my first scan, so I can use those use points on each one to align the multiple scans that I'm capturing. Again, I just pressed up on the scanner for my preview. We get one more scan from the back here. And that should be plenty right there. Okay, so what I just showed you was normal scanning, right? But you can turn on real-time fusion, and let's just look at that quickly. We don't need to do this, but I'll show you what real-time fusion does. Real-time fusion will use your dedicated video card to actively and in real time build a surface or a mesh of your object instead of displaying the raw frames that you're capturing. This is great for scanning demos. A lot of times it's really good for making sure visually you've scanned your object very thoroughly, because it's very easy to see what you have and haven't scanned. And that's about it right there for the real-time fusion. I think we're done. We're done with the scanning. So now what we're going to do, if you look at the results here on the right-hand side, I have my 3 scans, my 3 regular scans from just with real-time fusion disabled. But I also have this actual fusion. This is the real-time fusion that was created with the real-time fusion mode on. I'm just going to delete that. And then you can see, in addition to that real-time fusion piece, I still have raw data. But I don't need this one either, so I'm going to delete that as well. And that's it for the scanning. I'm going to stop my webcam here and move my objects out of the way. And we will now look at the processing portion of this. Okay, so when you're done with scanning, if you scanned in regular scanning mode without real-time fusion, when you close this scanning tab, I can press the little X here. You can see the bottom progress bar here. I'm just going to double click on here. It has moved on automatically to step 2 in that PDF, which is find serial registration. That is doing a kind of so during scanning, it's doing a rough alignment. Find serial registration does a finer alignment of each frame within each scan separately. If I had used real-time fusion, which I did, but I deleted those scans. If you use real-time fusion, it does not do find serial registration after you close that tab. The reason being, it's actually doing that in real time while you are scanning. But since we were just doing the regular scans here and I deleted the other ones, it ran it automatically for me. I'm going to turn my grid off here. After find serial registration, which ran automatically in my Tools tab here, I can move on to my eraser tool. So if I look in my workspace over here, right now I have an eye next to each scan. That means they're all active. If you want to activate just one at a time, which is what we want to do for the erasing portion, you can see each individual scan by itself. Now, we have these 3 scans that aren't lined up properly, but before we can align them, we are going to come in and erase the platform that it was scanned on. And this is very easy to do in Artec Studio. So that's step 3. We're going to come over here on the left-hand side to our editor. And I'm going to go to the eraser. I'm going to use this great function called the cutoff plane selection. So if I select that over here and bring my mouse over into my window here, if I hold Control, it brings up a little red circle, right? And you can scroll up and down with your mouse wheel to make it larger, smaller. What I'm going to do, I'm going to just paint a little bit down here on the platform. And you can see it puts this plane down there based on the surface that you painted on. And it's not quite right, so what I'm going to do, I'm going to hold Control and then Shift. Then I can scroll up and down with my mouse wheel to select where I want this to cut off. So I'm going to scroll up so I get the complete platform. I'm going to cut off a little bit of the feet here, but it doesn't matter because I scanned the bottom of the feet and the sides in my scans 2 and 3. So I'm going to click Erase here. Now I've gotten rid of that. And then I'm going to deselect on the right-hand side Scan 1 and select Scan 2 with I to make it active. And again, I'm going to come in here, cutoff plane selection, hold Control, paint a little bit, hold Control Shift, and scroll up a little with my mouse and click Erase. Very easy. Scan 3, if I come back into Eraser, there's also a couple other options here. I'm going to use the 2D selection for this one and kind of line this up sideways. 2D means that everything behind this selection circle is going to be erased. So I can just come in here just like this, kind of like in Photoshop or some other image editing program. And everything that's red is going to be erased. So I'll click Erase. And we're done with that. Easy enough. Okay. So after doing that, we have our 3 raw scans ready to go, but they are not aligned properly. They're every which way. So we have to line those up before we can fuse them all together. So if I come over here to my Align tab, this is step 4 in the PDF. Notice I have Scan 1 selected automatically. It's bold and it's blue. It has a blue dot next to it. So I can come over here and kind of visually line up my scan. If I come over here to if I select Scan 2 now, notice it places Scan 2 in here. It's not bold in the left-hand panel. It's got a green dot next to it, and it's still not oriented correctly. What I can do here is, if I click normally, if I left click, I can rotate. If I click down on my mouse wheel, I can pan. And then I can zoom in and out with my right-click mouse. If I want to move these separately, though, if I hold Shift and use all the same keys, I can move just that second scan. So that's what I'm going to do. I'm going to line them up visually here. And this is just to give you, to line them up visually so you can see common reference points. Okay, So there's a couple options here. I am going to leave texture align disabled. Most of the time, for most scans, you will leave that disabled if you have trouble lining things up just based on geometry. Maybe your object doesn't have very much geometry at all. You can use that texture align to help you line things up. But it does slow things down. I'm going to leave it off. There is an I'm feeling lucky button. It is exactly what it sounds like. Sometimes it works, sometimes it doesn't. I'm going to go ahead and click it and we'll see if it works. And it kind of worked this time, so but I don't like the way it lined up. It wasn't quite right, so I'm going to click this undo arrow here. And I am going to realign these visually. And we're going to do this the manual way, or kind of semi-manual way. So what I'm going to do is I'm going to click 3 common points on each scan. So I'm going to click his nose here. This seems like a pretty good one. If you select a point like I just did, you have to press the space bar to deselect before you can place another point. So that's good. I'll use his big toe over here. I just need to get close. Use his knuckle here. Okay, so that's pretty good. Now I'll click the Align Meshes button. And it looks pretty good. Now if you notice over here, the second scan has now turned bold. That means it is a registered scan, and it is going to always move together with the other registered scans. I could, if I needed to, right-click and click Unmark as Registered, and then move that scan around again. I could come down here if I knew that scan 3 was already aligned properly. I could right-click and say Mark as Registered, and that one would stay where it is as well, but it is not lined up, so I'm going to Unmark as Registered. And we're going to do the same thing we did before and visually line these up. And then click a couple common points. So let's go here and here. Let's use his elbow. And we'll use his heel over here. Align meshes. Looks like we're lined up and we're good to go. And that's it for the alignment. Pretty straightforward. I could have, this is the same for 2 scans or, 10 scans. It doesn't matter. You do the same process, just scan by scan. If you have trouble remembering what the keys are, there is this little quick help option down at the bottom that gives you kind of a quick overview of the buttons and keys to press while doing this. I'm going to click Apply, and we are done with step 4. Step 5 is global registration. So if I come back over here to my Tools tab, and I can expand any of these algorithms here. I click the arrow right next to global registration. And there is an option here to run using geometry or texture plus geometry. Most of the time, again, just like on the alignment function, you're going to use geometry only. But if there's something where there isn't a whole lot of geometry in your model and you have really good texture, then you may use your texture and geometry for registration here. But I'm going to do geometry only for this. I'm going to use the default setting here. This is the default for the spider. The EVA, I think, might default to 50, possibly, but you can leave those settings alone. Iterations is how many passes it's making. I'm going to leave this again at the default. You could increase that number and sometimes get better results. I could also just run global registration multiple times for better results. But I'm going to just run this as is, just like this. Right before I do this, though, if we look over here in the workspace, notice my quality numbers here. So I'm not going to pay attention to these numbers until after I do global registration. But I wanted to point them out. Right now they're at 0.2 and 0.3. Your quality rating there is always going to be the worst frame in the scan. So I can double click on a scan and see all my individual frames, and each frame has a quality number next to it. And again, that worst quality number, which is a higher number, the higher it is, the worse it is. So say a 0.1 would be better than 0.2. Your overall quality number that you see out here in your workspace references the worst quality frame in your scan. All right, so now that we looked at the quality there, I'm going to run my global registration here. And what global registration is doing is it's looking at all of my scans here that I have selected, all the scans with the eye next to them, and it is comparing all frames, making sure everything globally across all scans are lined up. It's like a fine-tuned final alignment of your scans. Okay, so global registration is done. If we look again over here at our quality number, I am now at 0.1, which is really good. For the Artec Spider, you want to see a quality number between 0.1 and 0.3. For the Artec Eva, you want to see a number between 0.3 and 0.7. Okay, so now that that's done, we can move on to the next step. Step 6 is outlier removal. So I'm going to change my view here so you can see this. I'm going to change my view to a point view. If you look at my scan, I do have some noise here around the edge. It's really not that bad, but there is some noise. On some scans, it could be worse than others. Outlier removal removes all of that noise. Now, if I expand outlier removal over here in my tools panel, I'm going to leave this the same. There are some notes in the outlier removal step on that PDF. Detailed notes about these numbers, but I'm going to leave this at 2. The resolution I'm going to leave at 3 because this resolution right here always needs to be higher than your quality number over here. So I could do a 0.2 if I wanted to, but when you're running outlier removal, you want the resolution here to be the same as your resolution that you use later on for the fusion, which we'll get to after this. So I'm going to leave this at 0.3. Take note again of the noise here. Not a whole lot on this scan. This is a nice clean scan, but I'm going to apply that. There are a few instances that I note on that PDF where you would not want to use outlier removal. Outlier removal you would use most of the time when you're doing Artec Spider scans with mechanical objects and such. If you were scanning things like hair or fur, something along those lines, you would not want to use outlier removal because it will count that hair or fur as noise, and a lot of times it'll chop most of it off. So you do need to be careful where you use it, and you will learn as you scan more what works with outliers and what doesn't. And this is just about done. Okay, notice all of that noise is gone. We have a nice clean model here. Okay, so after outlier removal, you can now move on to fusion. So for the Artec Spider, you're going to use sharp fusion for most things. The default number for sharp fusion on the Artec Spider is 0.3. The default for the Eva is 0.5. I'm sorry, 1. I believe the Eva is a default of 1. So sharp fusion here, I'm going to, again, when I mentioned in outlier removal, I was going to do a fusion of 0.3. So I'm going to leave my resolution here at 0.3. I could go down to 0.2 because my quality is 0.1. The lower this number, the more fine details you will see. If you have a really noisy scan, though, the lower your resolution, the more noise you're going to see. I'm going to leave my fill hole algorithm at watertight. There are a couple of other options. I'll talk about those in a second. And I will apply this. Again, note that whatever you have selected over here with an eye next to it is what is going to be fused. Fusion is taking all those individual frames that I captured and fusing them all together to create a single surface. Okay, so we're running Sharp Fusion right now, but there are a couple other options. Fast Fusion doesn't have any hole filling. It's fast, great for previews. Smooth Fusion is used a lot of times with EVA for people scans. It just results in a much smoother, it smooths out a lot of the harsh edges and everything. You don't want to use Smooth Fusion with the Artec Spider. I chose the watertight hole filling algorithm, which is great for if you're going to 3D print an object later. It's going to fill in all of your holes and make sure that you have a watertight model, which is needed for printing. There are two other options here. I could fill holes by radius, saying, fill all holes that are smaller than, in this case, 5 millimeters in diameter. I could also do a manual hole fill, which means when it's done with the Fusion, it brings you over to a manual hole filling screen, and you can click on the specific holes that you want to fill in. All right, so that was Fusion, step 7. Step 8 is small objects filter. So you have a couple options here. You can filter by threshold. For the most part, I say leave the largest object, which is going to leave, in this case, my sumo wrestler here. I'm going to click apply, and it will get rid of any kind of noise data that was left over from the Fusion that was floating around detached from the model. Okay. So the next step, step 9, is editing of your model. So after you're done with the Fusion, there may be portions of the model that you want to get rid of. Like, maybe I don't like this ponytail here or something. I can come over here to my editing tab on the left-hand side, and I'm going to use the defeature brush, which is different than the eraser in the fact that the defeature brush erases and then patches the hole. So I'm going to come over here to 3D selection. 2D again would punch straight through the object. 3D selection kind of contours to the surface, so you can select just what you want. So I'm going to come over here and just select this with my defeature brush. And it's going to delete that. Maybe I want to get rid of a little bit more here. And now I've deleted that portion of the hair. I can click apply. And maybe I don't like the edges here, so I can come into my smooth brush. And the smooth brush is very strong, even at its lowest strength. And again, for all of these editing functions, I'm holding control, and I can scroll up and down on the mouse to make my, my circle larger or smaller. For the smooth brush, you want to do this by clicking, right? You want to click. You don't want to click and drag. You just want to click little at a time to smooth that out. If you click and drag, you can actually remove, entire geometries here, which is not what you want. Okay, and then so I smoothed out some of the edges here. This hair where I removed that. Maybe I don't like this seam that was in the original model that I scanned. So I could use that to smooth this out. Again, this is just some really simple editing here. You would not want to do this with mechanical objects, but it works great for organic objects that you have scanned to do some quick modifications. So even if I hit apply here and I've put my changes in, I can hit Control-Z to undo the smoothing, and then I can hit Control-Z again to undo the defeature because I want all of my features there. So you can use your standard undo functions in Artec Studio. Okay, so that was step 9. Step 10 is mesh simplification. So if I come over here to my Fusion in my workspace in the right-hand side of the screen, if I double-click on that, it tells me that I have 666,156 polygons in this model. Depending on the software that you're going to export this into, that might be fine. If you are reapplying texture in Artec Studio, it's good practice to typically have your model under 500,000 polygons. Otherwise, it could take a long time to apply that texture. So what you can do if you do need to reduce this is come over here, back to your Tools tab, and use the Mesh Simplification options here. There's two options in Artec Studio 10. In Studio 9, there's only one option. So the first and original option that is in both versions, 9 and 10, is the standard mesh simplification. You can use this for mechanical objects, or if you want to keep the accuracy of your scan. If the very high accuracy level is essential to your project, then you want to use this. I could say, in this case, reduce this mesh until my points start to vary more than 0.01 millimeters from their current position. So I believe that's 10 microns. So if that's an acceptable accuracy or variation, then you could run it like that. But I'm not going to run this one. I'm going to run the fast mesh simplification, which is new to Artec Studio 10. And I'm going to set this to 100,000 polygons and click apply. And fast mesh simplification is quite a bit faster than your standard mesh simplification. Okay, so after that, I can come over here to my workspace again and double click my Fusion, and we have 100,000 polygons, just like I told it to. Okay, let's go back. Step 11, before you apply texture, you come over here to your Edges tab, and if after editing, even though I told this to make a watertight model during Fusion, after you edit the model, there could be some holes and imperfections in your model, in your Fusion, that were created during your editing process. If there were any holes here, they would show up here in this window on the left-hand side. I could select them, choose Fill Holes, and I would again have a watertight model. But there aren't any holes here, so I'm going to click Cancel, and we're done with that one. Okay, so during the scanning, if I come up here, I'm going to select my Scan 1 again, my raw data. I'm going to double click. And if I scroll down and find a frame with a T next to it, those are your texture frames. So Artec Studio automatically captures textures when it thinks it needs to. You can change that in the advanced preferences to capture every 3 frames or 10 frames if you want, but the automatic setting works great, so you can most people can just leave it there. When I apply texture, it's going to take all these individual texture frames and wrap them around the model, or this Fusion model that I created. So I'm going to reselect my Fusion over here in my workspace. I'm going to come over to my Texture tab, and I'm going to select all 3 of my raw scans here. If for some reason I did not want to apply texture from Scan 3, then I would just select Scan 1 and Scan 2. I'm just doing my standard Windows selection where I hold the Control key and I can click on additional options to add them to my selection. I'm going to select all 3 because I want to use the texture from all 3. I'm going to use my default settings here. Texture Atlas. In Paint, missing texture is an option that you will only see in Artec Studio 10, as well as the Remove Targets option is only in Artec Studio 10, but texture normalization is in Studio 9, and you want to leave that enabled most of the time. You have multiple texture resolutions you can use. I'm going to use the default of 4K. The texture normalization function, the reason you want to leave that is during scanning, sometimes you're closer, sometimes you're further from your object, and you get some lighter and darker frames. Well, texture normalization, that algorithm takes all those frames and it does its best to even them out. So you have a nice, smooth looking texture. and it is just about done here. Here we go. Okay, so here's my texture. Right before the final application of your color texture, it gives you these sliders here on the left-hand side. And I put some notes in that PDF under step 12 where you can actually adjust your brightness. I put in the notes the typical levels that you would use. So I might be around 0.6, between 0.6 and 1.6 and 1.8 for the brightness adjustment. Maybe like 0.85 to a little higher than that for the gamma. Somewhere in that range, right? I can adjust my hue if I want a little bit, if it's looking a little too green, which happens sometimes when you're scanning under fluorescent lighting. But if that looks good to me, then I can just click apply. And we are done with the texture application. Now, one more thing that you can do with the texture. In Artec Studio 10 only, this is a new function. In addition to the missing texture function where it automatically fills in spots that were missing during texture application. I can also come over here to my editing tab. This is step 13 on that PDF. And I can select this texture healing tool. This is great. I'm going to do 3D selection here. This is great for really simple, quick texture editing. So let's say we didn't want this logo here. I could come in and paint over this. And it's going to use the colors around it to do its best guess to fill in the texture that you erased with the surrounding textures. And again, you get some specular highlights here that you may want to fill in. These are because the object is a little shiny, so maybe I'd come through and just remove some of those. But it's just a really good way of removing small imperfections and such. I have a little black spot here. I don't know what that is. I can just get rid of that. Makes it really easy to edit that. I'm going to click apply, and it will apply those texture edits. Okay, the last step, step 14, is exporting your finished model. So if I look over here in my workspace, I have the little selection eye next to the fusion that I want to export. I want to make sure that is the only thing that I have selected. Otherwise, it will attempt to export other things together. It'll ask you if you want to mesh them together, and we don't want that. So I'm going to select just this. Go to File, Export Mesh. For my texture, I'm going to leave it at JPEG. If you're not applying texture, then it doesn't apply. And you have to click this little box with the 3 dots in it. And I could do File, Export, Sumo, and then I select the format that I want to use. You have STL, it's pretty standard, no color. OBJ carries color data. You've got your WRL 2.0 if you are exporting to a full color printer. That works really well. And E57 is also very common in the scanning world. And that is it for the Artec Studio 10 tutorial.